Welcome back, everybody. In this session, what we're going to do is just take a look at basic scripting. We're going to take a look at using MATLAB in its basic format, so getting it to commit to basic calculations and then looking at things operating. What I really wanted to do is try to spell out the functionalities and the benefit of doing two different types of ways, because they're not always obvious and they're not always straightforward. Again, if you have sat engineering applications with MATstables, this is probably going to be a little bit below your standard. It's just because you'll have met this type of techniques many times before. Right, so let's get started. So what I want to do is I'm going to start off with something dead basic. I want to look at response of sine and cosine, just looking at the basic process and looking at this over an entire cycle. So as we know, it's an oscillation between plus or minus of 1. So what we're going to do is first we'll use a command window. The beauty with the command window, love the command window. If I say x is equal to pi, now we use, I think that's a semicolon. You have to excuse me, dyslexia kills me sometimes. Now that will set my positive value. So I'm now saying I want to start at pi, then I want to move at variations of minus 0.1 through the entire cycle to, let me just close that, to minus pi. What this will do is cycle itself entirely across the process. Now if I click enter, this happens. You think, oh no, what have I done? Now I've in particular done one, I've done an error. I've particularly put an error into there because we need to use a semicolon at the end to actually close it. So if I stick a semicolon on the end, oh sorry, like that, what you can see there is the system now says, oh right, you didn't want to see everything in one hit. All you want to do is generate that as a variable. So I click enter. And what you'll see is that it doesn't regenerate the columns and giving me the long process behind it. So that in itself is quite useful. So let's do the next thing. Let's go. We've got x. Obviously, by any plot or any processes, we need a y. So let's go. Y is equal to. We're going to go sine. Close it. And x. Close it. And semicolon again, because if I don't, what it does, it gives me everything on the screen. You think, damn it, don't want to see that. Right, so now what we've technically done is we've solved just sine over a single cycle. So what I will do is now say to MATLAB, I want you to plot, open arguments. In here, if you wait a second, this is what you get. You'll notice there it literally says, okay, you've opened the plot tool. What I first need from you is I need an x. So in our case, we've nailed x. So let's say it's going to be x. Then if you look at the help beneath, you've got plot, x, and then comma. So if I go comma, you notice then it shifts the emphasis over to the y coordinate position. So if I go y, close it, boom. What we've actually got is we've got a full cycle process for it, and it's given us in essence what we're really looking for. You'll notice that we're moving between plus and minus as we'd originally intended. You'll notice that we're into plus or minus x and y, plus and minus x and y, so we know that our central datum point sits around this area. Right. Now, one thing that's a real benefit with that is that's a quick answer, that's a quick plot. I can see my initial response of the system dead quickly, dead simple, and I don't have to mess around with scripting, and I can just see what type of a system it's going to give me back, or what type of a response it's going to give me back. So this is where using the command window outright is such a benefit, because you can code it, hard code it straight in, see what's going to happen, test what's going to run, and then you think, no, I'm actually going to use this. So you can convert this, you can move that next level forward. So what I'm going to do is I'm just going to clear my workspace. Again, clear both sides. Right, so that is command window execution. What I'll do this time is I'm going to generate the same process through a script. What you see now is the editor opens. You'll notice it's marked as untitled. We are going to need to name it and so forth, but first things first, let's start to rebuild what we just did. Don't forget, we're saying x is equal to pi, and it's by minus 0.1, again by minus pi. Don't forget, I always forget, always. Close that line off. If you've done it right, any sort of errors that were appearing, you notice I had red line underneath my equals, is now been eradicated, and now we've got that finished area product, which is happy days. So let's move on to the next one. Let's say we need a y coordinates. Let's say y is equal to sine of x, and then close that off. Again, we've got a nice I thought it was not going to give it me then. Thinking, yep, I've already messed it up. Great start. Okay, so let's move it on a little bit more. So let's go on to plot. We open it up, and then as before, I got x, then I go comma y. Close that off. Close the brackets. One second. Right, so, sorry, somebody came to my office door. That is in essence what we've just written on the script. Now, as I said before, when you're doing anything like this, make sure you save this into an ideal spot. So, I mean, for me, I'm in my lecture notes. So what I'll do is I'm just going to go on MATLAB examples. And what I would recommend is that you create a folder. This becomes the folder for script. Now this is just, dare I say, this is my junk folder. I have all types of different things in here, different experiments I've tried. What I'm going to do is, I'm just going to click on the lower end of save, go save as. And what I'll do is I'm going to call this sine cos. Now, straight away, I've done an error. MATLAB does not and will not accept any spaces at all. It will always fail every single time. Make sure every single time that you save something, there is no spaces. So, I'm going to do underscore sine cos and save. If you don't do it correct, it should bring you up an error. If you haven't done it, if it doesn't bring you up an error, then I'm curious as to why it didn't. But anyway, right. So let's run this and see what it does. Boom, happy days. So we've now got our sinusoidal response. Let me just double check. Yep, sine into x over the time. And yes, so we're going x by y. I was just double checking then, making sure I'd not missed anything in particular. So let's close that. Now, the issue is with that is I've not added cosine. And when you think about it, it is dead straightforward, really. There's nothing major to it. So what I'm going to do is I need to create a new variable. Because if I say, again, y is equal to cos x, what it will do is it will overwrite my original value of y. So what I'll do is I will say y1 is equal to cos of x. Then by pure default I am now clear, because you'll see here and here I'm in two different variables. I mean, arguably you could call this sine y or cos y. It doesn't matter. These are a variable representation of what the values are that you're going to use. But if I run it, again, what it's actually done now, what it's done is it's plotted everything, but it's not plotted my... I'm sorry, I was just being facetious, just trying to make sure you were on your toes. What I'll do is I need to come back and then go, right, okay, come back to plot. Now this is interesting. I've seen a lot of people before and they've gone, oh, well, I'll just plot both sine and cosine by my X by default. To be fair, by default, that makes perfect sense. You know, you're using that initial value, but try not to think as that they are try to think of them as two separate representations. So in other words, the first two values that you see there are my X and my Y. What I'll do is put a comma on. What I could really do with doing is defining a colour. I'm going to go, let's have a think. Let's go red for sine, and let's go blue for cosine. Because as you know, if you have a very noisy data set, when this comes in, you're going to look and go, what the hell am I looking at? So what we do is I'll go apostrophe, I'll go R, and then close it. If I've done it right, what you'll see is that the letter goes a purple colour. This then confirms that it's correct. So before I even move on to anything else, let's just run it, just double check it. And there we go. Our letter now is in red. I mean, our signal now is in red. I'm going to replicate this process again, and we're going to go. Now, not to rabbit on too much, but this is technically classed as the first input. This is your sine response. What we're going to do is replicate that perfectly. So we're going to go comma X. We're going to go comma Y 1. So this now initially says, right, let's use X for sine. Let's make it red. Then let's use X for cosine. I'll go comma. And it really is this simple. Let's make it blue. If everything's done right, the red vanishes. Just hit save, because you've always got to be aware with MATLAB, sometimes if anything goes wrong, it will just crash and then you'll be screaming and shouting. Believe me, been there, bought that t-shirt. So let's run it. Not to sound too confident, but that's pretty much what I was looking for. We can shift the plot all over the place. We can control, in essence now, we're massively in control of everything. Sorry, 2 seconds. Yes, so we are in control of pretty much everything. We can shift the plots around, because don't forget, where we've gone pi minus 1 to pi minus pi, what we've essentially done is we've defined what our range will be. We can change that as much as we please. We change the frequency of whatever it is that we're running at. But let's not lose exactly what we're looking at. So the issue is now, if I take this to my boss, if you take this to your boss and go, right, that's my response, and I think, well, he'll probably look and go, that's a right load of shite. What exactly are you showing me? I'm not sure about what the hell I'm looking at. I'm not sure what all this is. It doesn't make sense at all. What in the hell am I looking at? So that can be a major issue. So what we're going to do is we're going to add a few things. We need some titles. We need units, because I mean, to be honest, that could be 10 bananas, it could be 1 mile, it could be 1 Newton, who knows. Now, biggest skeptical thing about all this is always keep in mind that if you're going to present something, make sure that you put units on, or else the values that you're applying to it are just values. They are not anything specific that we can use. So let's add something on. So what I'm going to do is I'm going to say add me a title, and I'm going to say add a handle. Now the system itself now will recognize this as something that I'm going to use. So I'm going to, because this has now become a variable, it will be a variable that is now called title handle. So then I say title, which the system recognizes. I'm going to open it, and I'm going to call this cos versus sine. Hell, you can call it anything you want, really. I mean, with this, it just depends obviously what it is that you're simulating. close the line off, you'll notice all my red's gone. Let's just check it. So I'm going to hit save and then run it. Haha, boom. What you can see there is a cos versus sine. So everything's now running. We've got a nice legend here. I mean a title here to really sell exactly what it is that we're doing. So it's great and everything though. We're missing something else. Missing an X label. And it really is this dead straightforward. So let's say X label. We're going to open it. Open a point. We're going to say X is equal to minus / pi to / pi. I am going to tell you in a minute why I'm using / because this little thing is another reason why I love MATLAB so much. So good. Right, so let's just run it. Oh, you just gotta love it. Look at that. X to minus pi to pi. It's actually showing me the particular value. I mean, it's showing me the symbol rather than anything else. And most of the time you have to put pi, then pi emerges. That / is the typical type format that it usually needs to recognize what it is. And I gotta love it. I'm such a nerd. Anyway, finally, let's stick a Y label on there. So we're going to go Y label. Open. We're going to add a comment. Open argument. X close argument. Then I'm going to close it off. Close the line. And then touch wood. Just realised, call that X, could just call that Y. And if you look now, what we've got is labels to each axis, we've got a title, and we're looking pretty swish, to be honest. It's one thing that I'm feeling very, quite confident about. Very, very confident about, in fact. So, one thing that we've not quite added yet is we've not added a legend. So what we could do is we could go legend, data 1, data 2. You can either change this, edit it to your suiting, whatever you please. We can code this. There's many different ways that we can control that. Now, that in a nutshell is the basics of scripting. Dead basic, easy process. What I would recommend is that you have a go at doing something else. Now, give me 1 second. So, finally, what I've done is I've added a double sign. What I would task you with is have a go at trying to plot this as an actual instance. Basic process. It is the multiple of the sine of the X wave that we've used. But just have a go. Get used to plotting it. And that's pretty much it, really. So I hope that you've enjoyed this basic process for plotting and a little bit of an insight to scripting. What I intend to do from here is move on a little bit more swift, move on to something a bit more juicy. Our next thing that we'll look at is a first order system. In essence, what we're going to do is we are going to look at using first order system to plot the performance of a door. We will look at the door shutting, and we'll look at the speed, the velocities of that door shutting, and we're going to try and map it against fire door standards and take it from there. So, hope you've enjoyed it, and speak to you soon.